In this video, we're talking about how to solve a linear system of equations with 3 different methods, which we'll call substitution, elimination, and graphing. So substitution and elimination should be somewhat of a review, but we want to talk about graphing as well in this example. So the example we've been given is the two equations x equals y plus 5 and 3x plus 2y equals 5. So we can solve this equation with substitution, and this one's already been done for us. What we want to do is solve for one of the variables and then plug the value for that variable into the other equation. In other words, make a substitution. So we've already been told that the value of x is y plus 5, which means we can take y plus 5 and plug it into this other equation for x. In other words, we're going to make a substitution for x. So instead of x here, we'll put in y plus 5 and we'll say 3 times the quantity y plus 5 plus 2y is equal to 5. So we made a substitution, and now we just need to simplify and solve for y. So distributing the 3 across the quantity y plus 5, we do 3 times y is 3y. 3 times 5 is 15. We have 2y, and we have 5. 3y plus 2y is 5y. Subtracting 15 from both sides, we get 5 minus 15 is negative 10. Dividing both sides by 5, we get y is equal to negative 10 over 5, which is negative 2. Now with the value y equals negative 2, we can plug this back in to an equation for x, and we already have that equation. We have x equals y plus 5, so plugging in negative 2 to this equation so that we can solve for x, we get x is equal to negative 2 plus 5. Negative 2 plus 5 is 3, so we get x is equal to 3. So then the solution to this linear system of equations is x equals 3 and y equals 2, or the point 3, negative 2. We can also come up with that same solution using what we call elimination. That's where we eliminate one variable from both equations so that we can solve for the other one. What we want to do is transform these equations so that when we add them together or subtract them from one another, we can get one of the variables to cancel. So the first thing we want to do is manipulate both equations so that all of the variables are on one side and the constants are on the other. The second equation is already in the correct form. We have the variables on one side, 3x and 2y, and we have the constant 5, the whole number, on the right. So we want to take this first equation and change it so that we have x and y on the left and the constant whole number on the right. So the way that we do that is by subtracting y from both sides, and what we'll end up with is x minus y is equal to 5. So we just changed this equation, so now it's in a different form, x minus y equals 5. Now what we need to be able to do is cancel one of the variables when we add these equations together or subtract them from one another. What we can notice here is that in the second equation we have 1y. In the first equation, we have 2y. So if we multiply the entire second equation by 2, we'd have a positive 2y up here and a negative 2y down here, which means that if we add the equations together, we'll get a positive 2y and a negative 2y, which will cancel with one another, leaving us with only x. In other words, we'll be able to eliminate the variable y. So that's what we want to do. We want to multiply through this entire equation by 2. So we're going to multiply by 2 like this, and when we do that, we're going to get 2x minus 2y is equal to 10 when we distribute the 2 across each of these terms. So now instead of this equation, we've got this one here. And now we can take these two equations and add them together, and it's just like a vertical addition problem. We add them together and we say 3x plus 2x is 5x. We say positive 2y plus a negative 2y is 0. Those two cancel with each other. And we say 5 plus 10 is 15. Dividing both sides by 5, we get x is equal to 3. Now we need to solve for y using our value for x. So we can take our value for x and plug it back into this equation up here. Any equation will do, but let's just go ahead and use this one. So we know x equals 3, and this equation was x equals y plus 5. So we'll say 3 equals y plus 5. Subtracting 5 from both sides, we see that we get y is equal to 3 minus 5, or negative 2. So again, we have x equals 3 and y equals negative 2, which we can call the point 3, negative 2. And notice how we got the exact same solution using elimination as the solution that we got using substitution. Now instead of using substitution or elimination, we can also use graphing to find the solution, because this again is just a coordinate point. So we have the two equations, x equals y plus 5 and 3x plus 2y equals 5. What we want to do is put both of these in slope-intercept form, which we have to do by solving for y. So solving this first equation for y, we need to subtract 5 from both sides to get y by itself, and we'll get y is equal to x minus 5. So that's a replacement for this equation. This equation, in order to solve for y, first we want to go ahead and subtract 3x from both sides. We'll get 2y is equal to negative 3x plus 5. Then we want to go ahead and divide both sides by 2 to get y by itself. When we do that, we'll get y is equal to negative 3 halves x plus 5 halves. Now we have both equations in slope-intercept form, and we can go ahead and graph them on an xy coordinate plane. So we have our graph here, and if we say 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and we'll try to make this as accurate as we can. So it's going to look something like this. Now, dealing with the first equation, we can see that our y-intercept here is negative 5. So we go down 1, 2, 3, 4, 5 to negative 5 right here. And then our slope is a positive 1, which means we're going to go up 1 and over 1 to the right. So we say up 1 over 1 is about right here. Up 1 and over 1 is about right here. Up 1 and over 1. So it looks like the graph of this line is going to be something like this. Now, we want to look at our second equation, y equals negative 3 halves x plus 5 halves. So our y-intercept is going to be positive 5 halves, so that's 2.5. We want to go up 1, 2.5. So there's our y-intercept right there. And then our slope tells us that we want to go down 3 and over 2. So going down 3, we get 1, 2, 3, and over 2 brings us to right about here. Down 3, 1, 2, 3, and over 2 brings us to about right here. And so then if we graph this line, it's going to look something like this. And this is a pretty rough sketch, but what we can see is that the lines intersect each other at about this point, which we can see is 1, 2, 3, negative 1, 2. So again, about the point 3, negative 2, which is the same solution we found using both substitution and elimination. So I just wanted to show you that there are 3 different methods you can use for solving a system of linear equations: substitution, elimination, and graphing, which should all give you the same solution as long as you've done the math correctly.